let's get started. My name is Payal Singh, and I'm going to talk about Postgres backups and recovery. How many of you, well, there's just 3 right now, work with Postgres primarily? Okay, and, okay, sorta. Yeah. Okay, so I guess for those who are curious, you will learn something good from this talk. Little bit about me. I'm a database administrator with omniTI. We're a consulting firm, and I primarily consult with Postgres users and clients. These are a few of the ways you can reach me. That's Twitter, GitHub, blog, and my email. Feel free to reach out to me if you have any questions about Postgres or any feedback about this talk. I'd be happy to read it. And without further delay, we're going to talk about types of backups that exist in Postgres. Validation. What does validation mean, especially when it comes to Postgres? What other types of validation? What is the minimum type of validation that you should be doing? Management of backups. Automation. Do you really need automation? If you have more than one cluster, then maybe you might benefit from it. But it's more of a decision on your part. What I'm going to talk about is this is how you do it, and these are the benefits you get from it. These are the pros and cons, and the decision is entirely up to you. File system. Are there any file systems that can enhance my experience of disaster recovery? Turns out there is. Spoiler alert, this is mainly going to be about ZFS. Heard about ZFS? Okay, that's great. And then third-party tools. If you're not satisfied with the tools that Postgres offers, if you need something more, there are tools out there, very popular tools, and I'm going to talk about the best of the best. And finally, an in-house solution. If you're not one of those people who are happy using external tools, you want full control, full authority, you want to learn more about Postgres, could be a number of reasons. And for any of those reasons, if you want to make your own solution, I'm going to be providing a few guidelines about how you can do that. Before we actually go on to the types of backups, there's 2 things, and it doesn't matter which database you're using, as long as you're responsible for the database, you have to discuss the RPO, recovery point objective, with your higher-ups, management, bosses, and even with your colleagues. So basically, any department in your company that could be affected by data loss or disaster, database-related disaster, you want to have this discussion with them. What is recovery point objective exactly? It's basically, in the simplest terms, the point to which you can recover. And that means that, so if the disaster happened at time t, and I can at most recover till time t minus 5, that's my RPO. So that's the latest data I can gather or save. And it's important for all the people involved to know that, to have their expectations not too high. The second equally important thing is recovery time objective. This is slightly simpler to understand. It's basically the time taken by the entire recovery process. And this doesn't mean just the time taken by PG restore or one restore command to run from start to finish. It also means the time spent until which you get the alert, which time spent for you reacting to it, planning, moving around files, talking to people, communicating, preparing everything, pre-restore tests if you have any, integrity checks, and that's your recovery time objective. One analogy or example of recovery point objective, because it's not as clear as the second one, is, say, you're taking backups every 5 hours, and that's going to be, so you're going to go to your managers and everyone involved and say, I'm going to, at any point in time, the maximum data loss that we will suffer is going to be 5 hours. And is that okay with everyone? And if it is, then you're good. If it's not, then you have to take more frequent backups, employ point-in-time replication. That's something I'm going to talk about ahead. And so, yeah, any questions about these 2? Okay. Finally, the types of backups. The first kind is logical. And these two are tools that come with Postgres itself. So if you have Postgres installed, you have these tools in there. And then the second kind is physical. Now, physical backup is of the entire file system, not just the data. So the way logical backup works is you run it, it connects to your particular database that you want to take a backup of, and it will gather all the data that's in there and make a dump of it. It does not know enough, it does not touch your PG data file system. It does not know enough about what's happening underneath the schema level. And sometimes it's great, sometimes it's not. You need a little bit more information, especially for point-in-time recovery. And for those, physical file system backups are highly recommended. And what happens in physical is the older kind was offline, where you have to bring down the database every time, then take a backup, and then bring it back up. Now, you might wonder, why would anybody even do this? Firstly, because online came in later, and also because offline is easier. So when you take the database down, nothing's happening on the database. So when you're creating a file system backup while nothing's happening on the database, it's simple, it's consistent. You don't have to do anything aside from it to make sure that the backup is consistent. Whereas if you have online, that is basically changes are being made to the database as you're taking a backup. There's something extra that you need to tell Postgres, and some other checks in place that you need to have to make sure your backups are consistent. However, for most of us, even with the ease of offline, we're not going to choose it. And so I'm completely going to ignore and pretend as if offline physical backup doesn't even exist, because I highly doubt anybody would want to do that. Yes.
What's the difference between PG dump and PG dump all?
Yeah, I was about to cover that. So basically, PG dump, I'll be happy to talk about it right now. PG dump, so in Postgres, if you're coming from the MySQL world, that I'm assuming, in Postgres, the terminology is a bit different. So when you, on a machine where you have Postgres installed, that's what's called as a cluster. Within that single instance of Postgres, you can have multiple databases. And so a cluster is basically a collection of databases on a single machine. And so PG dump, what it does is it connects to a particular database within the cluster, not the cluster itself. And there's certain advantages that I'm going to cover, but the main difference is that PG dump all only connects to the cluster. It cannot connect to the underlying databases in the cluster. So basically with PG dump, you have higher granularity. You know, okay, this is the specific database that I want to back up. Whereas in PG dump all, it's, okay, I have to back up the whole cluster. I'm going to do exactly that. I would always recommend PG dump, and I'm going to talk about why. Yeah, no problem. So logical backups, PG dump and PG dump all. The first thing, as I already mentioned, is granularity and fine-tuned restores. So not only with PG dump especially, not only can you connect to one particular database, you can tell PG dump, I only want this particular table dumped, or these groups of tables dumped, or these groups of schemas dumped, or I only want the schema design to be dumped and none of the data. And so you have a lot of flexibility in terms of what exactly you want in the form of your backup. Why it's important, we're going to look at a number of use cases that will make it clear. Another very important thing with PG dump, not dump all, is that compression is supported with PG dump. You don't have to have external tools like tar or zip to do that. And lastly, ease of use, no extra setup required. If you're running Postgres, you can run PG dump, you can run PG dump all, no external dependencies, you should not face any problems just running the command straight away. PG dump all's granularity is a bit different. So while, as I already mentioned, it connects to the cluster, not the underlying databases, the advantage of that, and PG dump cannot do this, is dump all can look at global variables that are common to all the databases within my cluster. So what that means is, in Postgres, I'm not sure about MySQL, but in Postgres, all the roles users, groups, and access privileges of each of these users and groups are global variables. They are not common. They're common amongst all the databases in my cluster. And so pgdump, because it can only connect to the highest level is a database, it cannot access these global variables, whereas pgdumpall can. So what I would recommend is if you go about doing logical backups, make sure there's an option in dumpall to just dump out the roles, not any of the data. So typically when you're setting up logical backups, I would suggest that first you use pgdumpall to only dump out the roles, and then you use pgdump to dump out the specific database that is your concern or specific tables and such. And the advantage of doing this is when you're restoring, you don't have to worry about the roles. First you restore the pgdumpall file, which is going to be very small, and then you restore the rest of the data, which is the pgdump backup. There are certain disadvantages to logical backups, but most of these crop up when you start comparing it with file system level backups. So inherently these are good. However, they tend to be slower when compared to file system level backups, and understandably so. They don't have detailed access of the file system. They're not talking to the operating system directly. They're talking to Postgres. And as a result of that, their snapshots are frozen in time. So there is no way you can do point-in-time replication. Again, apologies, I'm going to cover it later in a separate section about what PITR is. I'm assuming we don't know much about it here in this room. Okay. And finally, locks. Logical backup, pgdump. Whenever it's dumping, so it dumps table by table, and whenever it's dumping a table, it has a lock on it. Not an exclusive lock, but a read lock. So if some other operation is going to require an exclusive lock, it's going to have to wait. And that can create issues. So if you have a very large table or a very large database, it can sometimes be infeasible to use pgdump and pgdumpall. And that's when the file system backups really shine, where they do not take any locks. Finally, the data is spread in time. So because I already mentioned pgdump, the way it works is it goes table by table, takes a lock on table A. Once it's done with dumping out table A, moves on to table B. And because it does it this way, table A's backup is going to be at a different point in time than table B's backup. So the data is spread in time. That's not necessarily a bad thing, but it could be depending on your application. So keep that in mind. The latest version of Postgres 9.6 and even 9.5 have an option to use parallel pgdump. But again, you cannot tell it to dump out specific tables in parallel. That's a decision Postgres will take itself. So even then, if you're taking a lot of tables, it's going to be spread in time. Yeah. But yeah, so basically, you're right. You cannot actually tell it to do it in group at a single time. pgdumpall. The biggest pros that I already mentioned is global variables. Cons, why pgdumpall is not recommended is firstly because it's less secure. You have to give it super user access to be able to access its cluster. And it makes sense, right? Because in a cluster you have multiple databases. Now any user that has authority to go into each database, read each user's data and do everything has to be a super user, most often than not. And so if you want to use pgdumpall to dump out all the data in your cluster, you have to do it as a super user. No granularity while restoring. If you decide to go with pgdumpall, not pgdump, and use it to take a backup of your whole cluster, you have to restore the whole cluster. You cannot choose which table or which database or which schema to restore. No compression is supported. pgdump has compression, pgdumpall does not. And it cannot take advantage of parallel restores with pgrestore. So one thing that's important to note is pgrestore, the restore tool in Postgres, only works with backups of pgdump, and that too when they're compressed. So any plain text backup by pgdump as well as pgdumpall will not work with pgrestore. You have to use PSQL, the generic utility for Postgres, to restore a plain text backup. Because pgdumpall cannot support compression inbuilt, only PSQL is the way to go to restore it, and PSQL doesn't have a parallel option. PG Restore does. It has a parallel option for the last several Postgres versions, so it's much faster. So you lose out on speed. Any questions so far? Okay, I'm going to talk about physical backups now. Naturally, physical backups are faster. There is also an option for incremental backups. If you're using a file system like ZFS and you're taking snapshots, and there's a possibility to take incremental snapshots, which is basically storing the delta between the last snapshot and the current one. And so they tend to be really fast, and basically a fraction of a second, even less, depending on the size of your database and your file system. Point-in-time recovery is possible. So because file systems can actually access the underlying details of PG data, they are able to know how to use the archive files, the files that Postgres produces when it does anything, write-ahead logs. So it has access to those files. It has enough detail about the file system implementation of Postgres to know where to apply them. And so it's possible to do point-in-time recovery, which is basically at any point in time, if I have a base backup and all the logs, write-ahead logs, I could restore my base backup, and one by one I could restore the write-ahead logs, run them on my base backup to bring the database back up to a certain point in time. I could choose when. So that's a great benefit, right? You cannot take base backups every second, but you can have wall archives every second, every minute. And it just gives you tremendous strength and confidence that you can restore up to any point in time. And that's where physical backups really shine, aside from them being faster. Compression on certain file systems is available. Do note that ZFS does have compression, but by default it's disabled. So you actually have to enable it if that's something you want to take advantage of. It lacks granularity. You're taking an entire file system's backup, you have to restore the whole file system. Why do you need both kinds of backups? Well, the more the merrier. Database-wide restores. So let's say your database got corrupted, or somebody just did a drop database command, or somebody just changed permissions and now it's all just basically turned into flames. You basically have to restore the whole file system, the whole PG data, or most of it anyway. And so what's going to be faster is a physical base backup, and then point-in-time recovery, because physical backups are faster if you have the same quantity of data to restore compared to logical backups. However, if, say, somebody just dropped one of the tables, it's not a very big table, it's not contributing to the size of the whole database, if you have logical table backups, you can just restore that one table from its backup file. And so that adds to the speed. You don't have to restore the whole PG data to be able to do that. More often than not, I have seen that it does happen that the whole database is down and you need to restore file system to be able to bring it up, but do not ignore logical backups, because it's more often than you would think that something goes wrong in one of the tables and developers just want it to be restored back in time, and you can do that if you have logical backups. Yes?
Does physical backups need to be taken from the active master to actually let's say, for example, if I'm taking a physical backup from the standby master,
Yeah.
and the main master crashes, is that file system good to be a recovery?
Yes, it's possible. And in fact, it's encouraged. We are going to look at certain disaster situations where you would not want to touch the master. If, let's say, you have 5 slaves, you only want to touch the master once to create the one slave. For the rest 4, you just want to copy the base backup from the slave that you created. So it's actually recommended to do it on the slave.
Speak a little bit about once we recovered the main master, how do we point the position?
Sure. I will cover them when I get, no problem. So the first kind of PG-based backup is what basically your question is the answer to your question. It is like pgdump and pgdumpall, a tool that comes with Postgres. You don't have to externally install it, no external dependencies. Very nice tool. I would definitely recommend it if your file system doesn't have great tools of itself. This is what is going to replace it, and it's not a bad solution at all. It is in core Postgres. There is no explicit backup mode required. So remember when I talked about offline versus online physical backups and restores, I said that in online, to ensure that your backup is consistent, you have to do something more. That something more is basically talking to Postgres and saying, hey, I'm going to start taking the base backups right now. So can you please ensure that all the changes that are being made to my database, which is basically in the form of write-ahead log files, you preserve them. You don't let them go. Even if your slave has replayed them and it's time for you to throw them away, I'm putting you in backup mode. Unless I lift this flag up, please do not let go of them. So in normal file system backups, when, say, you're using ZFS snapshotting for file system, you have to explicitly tell Postgres to start backup and stop backup before and after the snapshots. Whereas in PG-based backup, that's internal. A lot of the other things, consistency and integrity checks of your base backup is done by PG-based backup itself. So basically, you're good if you just straight away run the base backup command and do nothing before or after that. So that's a very convenient solution. Multiple instances of PG-based backup can run concurrently, but as you asked, as your concern was, you do not want to do that, especially on your production master, because it comes at a performance penalty. The more instances of PG backup you run at the same time, the slower, the more bandwidth it's going to take, basically. Backups can be made on master as well as standby. So you can first, so let's say you had a failover after a disaster, and you're rebuilding your slave from scratch, although if you're on 9.5, you don't really have to do that, because there's an option PG sync for that, which basically just syncs your slave so it avoids you from rebuilding the slave from scratch. But if in older versions where you have no option but to rebuild the slave, you can use PG-based backup for that. Once you rebuild one of the slaves, you can just either copy the PG data or use PG backup from those slaves for the rest of the locations and just do it. So yeah, pretty convenient, very nice. Just a few disadvantages compared to some other tools that are out there, and basically, in my mind, it's CFS snapshot. PG-based backup is going to be much slower. It's not instantaneous by any standards. And also, backups are always of the entire cluster, which is not really a base backup disadvantage, but a file system disadvantage. There are a few requirements if you decide to go ahead with PG-based backup. The first thing is it does require a super user or a replication user. This is not a big deal, though. If you have a streaming replica, if you do have streaming replication, it means you do have a replication user already. So just use that. Make sure that archive command is set. You are sending Postgres, storing Postgres wall archive logs somewhere. It's not just going to go to dev null. Max wall senders is another parameter in PostgreSQL.configuration file, which should at least be set to 1 if you plan to use PG-based backup. What it basically means is that it tells Postgres that you can send your wall logs to these many locations. So by default, it's 0. Basically, you cannot send it anywhere. You at least want it to 2. That's my recommendation, although officially it's 1. Why 2 is because let's say you already have a streaming slave that is streaming wall logs from master. That's what is going to take up the 1 slot of max wall senders. So if you're using PG-based backup for a separate daily backup, it's going to happen in addition to the 1 channel that's already being taken by your streaming replica. So you need a second one for that. So even when you're starting out, you do not have a streaming replica, it's always good to look forward. It will save you an inconvenient restart, because this setting change requires a restart of the database. So set it to at least 2 and you should be good to go.
Is that on the target server, or that needs to be done on the master?
This needs to be done on the master. This is a master specification. Yes. Archive command, on the other hand, does not require a restart. It just requires a reload. So that's, even if it's not said, you can change it anytime you want, but not this one, not Maxwell senders. The next kind of backups I'm going to talk about, so that was the two main formal kinds of backups that you should have no matter what if you're using Postgres in production. There are other kinds of backups that can come to your rescue in certain unique situations without really demanding too much of your resources. The first one is delayed replicas as backups. What it basically means is if you have streaming replication, most of the times by default, if you're going to create your recovery file and set all the settings there, by default it's going to be in the latest format. So it's going to replay as soon as the master sends the wall logs over, right? There is an option to delay that, and you might wonder why someone would want to do that. Let's say your delayed replica is 15 minutes behind, and someone dropped a very important table on your master. You still have 15 minutes to stop replication on this delayed slave, take the backup, restore it onto production. And this doesn't have to be just a dedicated delayed backup that nobody uses. This can be used for reporting. Reporting generally doesn't require the latest data. So you can use it as reporting, but have it as a delayed slave. In fact, it did help in a major way for one of the big cloud companies earlier this month, 5th of April, when they had an outage. And it says, the part in red, within 3 minutes of the initial alerts, we discovered that a primary database had been deleted. This is straight out from their incident response. And 4 minutes later, we commenced the recovery process using one of our time-delayed database replicas. So that's how it saved them. There are questions as to why they chose this method, because they say it took over 4 hours for us to restore it. Now, one would say if you can, if they could have waited, depending on how much delayed that is, let's say 15 minutes, they could have waited 15 minutes, waited for this replica to be completely caught over, and then just failed over to it. You can't fail it over. And that then their outage would just have been 15 minutes. But they decided to go this route. I don't know why, but the main point is it saved them, and nothing else did.
So one delayed replica can be promoted as main master at any time?
It is just the same as any other replica, streaming replication you have. The only difference is it's replicating slower. Yes. So if you wait 15 minutes, it's going to be completely caught up, assuming that which is the case, that the master database was down, so nothing else was happening on the master. Version control DDLs is another non-formal kind of backup strategy that you can have. Again, doesn't require a lot of resources, especially if you have a lot of stored procedures and functions and triggers in your database. I would highly recommend having this in place. So some of you might have heard of the term change management or schema change management. This is sort of like that, where so there's a tool called PG Extractor, open source, available on GitHub. It basically is a wrapper around the PG dump command. What it does is for each of the functions that you have, it creates a separate dump file for each function. Now, once you have this, have all the function backups as a separate file for each, you can version control them, say every night. So that way, if, say, on a Sunday, something fails, a function fails, you can look at when somebody made a change to it last and figure out and find the source code that existed before, restore it back, and you're okay. So again, for functions especially, this comes in very handy. That was all about the types of backups. Any questions? Okay. Yes. You can do a data backup. In fact, we do it. But if you're tight on resources and you think that, okay, I already have D-rate replicas and logical and physical, at least do it for the functions. So that's the least that I would recommend. But you can do it as a data backup. Pardon? I would recommend using that, yes. And PG Extractor doesn't only dump out functions, you can also dump out each table per file and each database object per file. But functions is where it really comes in handy in my experience. Yes?
We don't have right now a CFS. We use XT for systems.
Mm-hmm.
Does that come with a? I mean, it might be slower, but it's still everything functions the same thing. It's a file system.
Yes. However, in my knowledge, ext4 does not have snapshotting capabilities.
Okay. Yeah.
So,
that will be depending on
yes.
whatever storage we have for the data here.
Yeah. But for all of this purpose, whatever we've covered so far, you're good.
Okay.
Yeah.
And last question.
Sure.
I have been running backups from the Postgres user. So from what you said, it will be just a matter of create another user and specify some sort of privileges to allow it.
Depends. If you have if you have streaming replication right now, I would suggest you look at the user that's being used to stream. In my knowledge, it will most probably be a user called replication, like literally. So you can use that role. Postgres is a super user. If you're really paranoid about security, just use the replication user. Yeah. Moving on, database backups validation. The first thing that you want is to have estimates and expectations in place, testing in place, and why is it important? It contributes to the recovery time objective. It tells everybody, this is how much time it's going to take me to do it. More importantly, you need to know, does your backup really work? So the only way to know it for sure is to restore it. Other ways of ensuring your backups work is if you have dev databases, make sure you talk to the developers and set up periodic refreshes. That's a good way to test. Also, reporting databases often are refreshed every night because they need reports for the data that was generated yesterday. And so that's, again, a great candidate for daily validation. This is a sample log just to show you that how a validation script would run. It's basically a restore log. At the end, it's checking everything and saying it's all okay. So the way we make it work is if this is not all okay, if there's an error, we tell cron to email it to us. So the next morning, we know that, okay, something went wrong. Oh, yes, this is the actual restore log. Yes. And so every morning.
This was like the reporting database.
Yes. And this is on so you're testing your backups in the form of a reporting database in this case. And every morning when it finishes, we have this log sent to us in email. If you're one of those people who don't like daily emails like this, you can just set it to email it to you if there's an error. But yeah, this is the actual log that's generated every morning. Now, GitLab not so long ago had an issue, I think in mid-February, where all its backups went somewhere, and it wasn't able to restore in time. And we're going to look at some of the things that it said in its incident response pages and see what happened. So first they say that backups were taken once per 24 hours, not yet being able to figure out where they're stored. They don't appear to be working. That shows that it did not have point-in-time recovery in place, so the newest that they had were 24 hours old. No alerts for missing backups. They did not know if they were working. No documentation. They did not know where it was stored. And no restore testing, obviously, because they did not know the rest of the things. FogGem, I don't know what that is, may have cleaned out older backups, they say in that incident response. That shows they did not have a retention policy in place. They did not know which backups will get removed when. Our backups to S3 apparently don't work either. The bucket is empty. If they had the monitoring and alerting in place, they would have known that. And finally, unless we can pull these from the past 24 hours, they will be lost. they did not have a recovery point objective in place. So they were short on time. They were very, very anxious. And they were also live streaming it, video streaming. I'm not sure if anybody followed it, but it was a lot of fun. However, the intent here is not to make fun or criticize GitLab. It's more to see that so many things can go wrong if you do not take disaster recovery seriously. And a chain is only as strong as the weakest link. It's a sobering thought to realize at the time of a crisis, only one of those things is enough to take you down and severely delay your recovery process. All of those things do not have to go wrong. And so, yeah, is it really something that you want to rely on luck, especially in things like this? So, yeah. On to management. Whoops. On to management. The first thing is retention period. We've already talked a little bit about it. Basically, how much backups do you want to have, do you want to retain? So you can either choose a retention policy that says remove all backups older than X days, 10 days, let's say, or you can have a retention policy that says remove all backups older, remove all but latest 10 backups. And those are not the same thing. You might have multiple backups taken in a day. So make sure what is it you want to do. And then there's off-server and off-site retention, which is basically a backup, the copies that you're storing within your infrastructure and the copies that you're storing for long-term storage outside of your infrastructure. Let's say you're uploading to S3, Glacier, or any such cloud storage service. Security, just a quick look since I'm apparently short on time. Security is, so the first thing is in transfer, especially when you're setting up replication, make sure you have passwordless SSH access. Make sure you don't have two-way access because you really don't need it. You only need the slave to be able to talk to the master. HTTPS for cloud uploads, if you're uploading backups to S3, for example, make sure HTTPS is on. Storage, make sure encryption is on if your data is really sensitive. ZFS has the option for encryption. I'm not sure if the file system that you're using does, but there's no harm looking and checking to see if it does. If it does, it's great. Access control, always important in a database. PCI compliance, if you're managing credit card data, make sure that your private keys are stored separate from your PG data environment. So that way, when you take a backup of your PG data, your private keys are not a part of that. You don't want your private keys to go along with your backup if something gets stolen. And then multi-tenancy environment. I don't think you might go through this very often, but let's say you have several clients on a single global machine. And if that's the case, so normally when you're taking backup of a client, your backup script resides on the client, takes the backups, and sends it to a backup server. However, if you have a multi-tenancy environment, you do not want all the clients to have access to a single backup server. So you have to do it the non-intuitive way, which is tell the backup server to contact each client one at a time, take the backup, pull it back in, and then so on and so forth. Next up in management is monitoring and alerts. There are several classifications to be made, but this is often one that I think is missing. Make sure you have multiple time level of alerts. Maybe not the right way to say it, but so the first kind of alert you should ensure you have is alert at runtime. These are immediate. You can do this through cron scripts integrated with PagerDuty, right? When your backup script is actually running and it fails for some reason, cron should email you. Or if it's integrated with PagerDuty, it will call you. The second kind of alert is secondary or delayed, which is basically retention scripts. So if your retention script runs and notices, oh, for the last 2 days I haven't had a single backup uploaded to S3. That's not expected, so I should let the DBA know. So that's a little bit delayed. So if the first one fails for some reason, you have a second one, which after a certain point in time is going to tell you something's wrong. And finally, there's alert on backup validation, which we already talked about, that if something fails during restore, you need to get informed. I would recommend for backup validation related alerts, you do want to get paged. It's important. Backups are no use if they cannot be restored. Because S3 is such a popular cloud platform, I'm going to talk a little bit about it. Just not much, just the fact that it's cheap, it's got a lot of space. When you upload backups to S3, you can upload it in parts. So if something fails, you don't have to start from scratch. And the speed depends on the bandwidth. Security is really great in S3. You have multiple levels of security in the form of buckets, which are basically directories that you have, and users that you have everywhere. And you can set policies on both of these. You can have user-based policy and bucket-based policy. Communication, there are ample ways in which you can communicate. You can have encryption enabled. You can also have access keys enabled. Just a quick look at what a policy would look like. So this is a bucket policy. Basically, you're telling the bucket that this user can access these aspects of you. So basically, in this case, the omniTI testing user can access all of the bucket itself and its subdirectories. And this is a sample user policy, which basically says as a user, you are allowed to access these resources. So basically, they're both the same thing coming from different ends. And if you want, you can set them both up, but it's not required. A look at automation. Why do you need to automate? Turns out backup management is a little bit more than just using pgdump and pgdumpall. So far, we've talked a lot about these things. So it turns out that, yeah, you might just want to automate if you are managing multiple clusters. It's less work. You can move scripts around, especially after a failover. You don't want to do all of that stuff manually, so it really shines then. Basically, you want to automate your scripts in the form of templates, cron tabs, accesses, and your restores. So daily restores, you obviously don't want to do them manually. And yeah. Just a quick look at so Chef and Ansible are the two configuration managers I'm familiar with. This is just an overlook of what it would look like if you create your own automation. The first part is basically the subdirectories that you will have. The second part is the files that I actually have, the template files. And so basically it's backup, offsite backups, dump, configuration for pgdump, configuration for uploading to S3, actual upload script, and actual start backup script, which is putting it in backup mode. These are just some of the scripts I have. You don't have to have all of these, but it's, yeah, there it is. Ansible tends to be a little easier, especially on a smaller scale. So if you don't have those many clusters, it would be simpler to go with Ansible. Basically just giving it a shell command to run pgdump and then telling it to upload to S3 with the AWS CLI. Just telling it where to upload and giving the upload command, and that's basically it. A little bit about my favorite file system. It's now on Linux, and it's improving, but it is okay to use in production. It is safe. But again, do so at your own risk. It's still new. One favorite feature that I have is ZFS rollbacks, and that especially helps disaster recovery when, say, you're using upgrade with hard link option. So basically that option increases the speed of your Postgres major version upgrade greatly. And so once that happens, the side effect of that is if the upgrade fails for some reason in between, you cannot go back and use your older cluster. You cannot go back and use your older data. However, if you're taking ZFS snapshots, you can use the ZFS rollback command to roll back to a particular snapshot in time, and hence, if an upgrade fails, you can do this, and you can continue to use your older cluster like nothing ever happened. So it's almost magical, almost. Another great quality of ZFS, yes?
It's doing that within its own nature, right? It's internal to ZFS. It's not like you're telling it.
No.
Calling it.
The one thing I'm calling is the last part. That is the command that is sudo ZFS rollback and the snapshot name. But aside from that, everything else is handled by ZFS. It's as simple as it looks. Again, similar to the last one, there's something called ZFS clone. And again, it's literally the command sudo ZFS clone, name of the snapshot, and the place where I want it to clone or get copied. Now it's copy on write, which means that when I initially clone it and do not write to the clone, it won't take any additional space. So that's just amazing, right? For certain situations, it can be great. Once you start writing to the clone, though, then it will start taking space. But in things like disaster recovery, you don't usually write to the clone. You just need a copy to salvage one particular table from a certain point in time. And that's what ZFS makes possible. Quick look at external tools. Most of these external tools provide everything that you need for file system backups and point-in-time recovery. First is omniTI. The winning feature of this one is comprehensive logging. It's very easy to debug problems in this. The logging is just better than most other third-party tools that you will find. A very popular tool.
Is it like free?
Yes, everything that in my talk, every tool is open source and completely free and available on GitHub.
So this is developed and supported by the company?
Yes, yes, yes. And it's the oldest tools amongst all these third-party extensions. Then we have Barman, which is, again, very popular tool, provides all the same features. I would recommend Barman if the infrastructure you're managing is so great that you actually need to manage all the backups in a central location because it requires a particular server, especially for Barman. So if you are really dealing with a large-scale infrastructure, Barman is probably the right tool to go with. And finally, Wall-E. The winning factor of Wall-E is cloud integration. So it's inbuilt integration with AWS S3 commands is great, especially like you can set Postgres to directly send wall archives to S3. And you can do that with Wall-E. You don't have to have any manual scripts or do any complex tasks to make that happen. Finally, the in-house solution. I know this looks like a mess, and you don't have to go through this, but this is just to show you that this is all it takes to make your own logical backup script. So what this is doing is basically it's going through a file, a configuration file, reading the list of databases to dump out and dumping them out one by one with the options for each database that you can specify. I'm going to be uploading the slides, but yeah. Physical. This is literally the PG base backup command that you can just run and get a base backup. Make sure you have the XS property set that basically says that keep streaming the wall files to wherever I'm sending the base backup. So that is particularly important. ZFS snapshots, again you can see, so there's an offline option and an online option. The first one is online, where I have to tell Postgres to go in backup mode and come out of it. And between it, I'm actually doing the ZFS snap function. So these are just the function names, not the whole code, but just to give you an idea that it's not terribly complicated.
How often do you do this?
Every night. So yes, and because it's instantaneous, there's no load. And in fact, for terabyte-sized databases. Oh no, this is just the snap. We don't do rollbacks. Is just. We are doing that every 30 minutes for rest of the stuff, but this one major, the whole snapshot that we're sending to the backup, so that takes time, so that we do nightly. But yeah, we are doing snapshots much more frequently, which we store locally. Yeah. For S3 backup, again, basic step is check that it's the only instance running, take the dump, encrypt it, upload it, move files around, and finally clean up everything. When you say move files around, I would suggest that when you're deleting the local copies of the backups after uploading, if you can, please continue to store them for like a day or two if you have ample storage on your systems. Why? Because that is another kind of backup that can save you. Redundancy is good. Not too long ago, the Register posted an article that basically said an SA removed all the backups and deleted all the VPNs of this company because he was really angry and he had access to everything. And he also made sure that none of the offsite backups were there, so no backups. However, by accident, they did have the backups lying around on the local machine on which the database resided, and that's what saved them. So as much redundancy as your storage allows, I would encourage it. This is disaster. Finally, just to look at what your S3 backups monitoring scripts would look like, and basically it's just getting a list of the files, extracting the date, comparing it with today or yesterday, and if it sees that no such file exists that has the date timestamp today or yesterday, it's going to email you or alert you. Finally, the backup documentation. Do not ignore where you're storing stuff, how you're storing it, how to restore it, because you might not remain in the company forever, and you might want to make things easier for the one next in line. Some of the references that I've used, and I am done with a minute to go. If there are any questions, I'd be happy to answer.
So do you recommend doing both the physical backup and the logical backup as well? So like maybe logical once a day and physical as well?
Yes, I would definitely recommend that. Yeah. That's it? Okay. Thank you very much. Thank you.